Part 2, slopes of parallel and perpendicular lines. When two lines have the same slope, congruent triangles can be drawn to show the rise and the run. So if you have a look at this picture, we can draw a triangle, so a rise, run, and then finish the triangle with the line itself. Okay, when two lines are parallel, we can draw the triangle on the other line, and look, those triangles are exactly the same. They have a rise of 7, a run of 5, and of course if we use Pythagorean theorem, 7 squared plus 5 squared, okay, is going to be whatever that line is, okay, and it's going to be the same on that triangle. So we have congruent triangles. Okay, so lines that have the same slope, they're called parallel. Okay, so the slope of AB is 7 over 5. The slope of CD is 7 over 5. And we use this little symbol here. So we say that line AB is parallel, okay, to line CD. Okay, so we use this kind of double slash to signify parallel. Okay, so the classic example of parallel lines are train tracks. Of course, those would never intersect. They would run concurrently beside each other, because what would happen if the train tracks weren't parallel, right? As the train gets further down the track, the wheels get closer together, and that would just be disastrous for the train. So, anyways, example 1, interpreting the slope of a given line. So, if line EF passes through E, -3, -2, and F, -1, 6, CD passes through that, and AB passes through that and that. Okay, are these lines parallel? And then use the slope formula to justify your answer. So really, all we have to do here is we have to find the slope of all three lines. So we do that by going M for slope, so MEF. Okay, so remember the slope formula, and I'll write it up here. It's on your formula sheet, but y2 minus y1 over x2 minus x1. Okay, so let's call this guy x1, y1. We'll call f x2, y2. Okay, so then y2 is 6, so 6 minus -2 over -1 minus -3. Okay, we just plug those into our calculators, or we can do them in our heads. Double negatives make positives, so 6 plus 2 is 8. Okay, -1 plus 3 is 2. So the slope of EF is 4. Okay, great. So we can't say parallel or perpendicular yet because we have to figure out the other slopes first. So now we do the same thing, slope for, let's go CD, because that's next, so might as well. Okay, let's call that x1, x1, y1, and then we'll make dx2, y2. Okay, remember, the order of that isn't important. I could make the C x2, y2, and the D x1, y1. It'll work out exactly the same. Okay, so y2 we're saying is 7. So 7 minus -3. Okay, and then x2 is 1 minus -1. Okay, so let's see. The double negative becomes a positive, so that's 10. Again, the double negative becomes a positive. Oh, look, so the slope of CD is 5. Oh, okay, well, that's no fun. So those are not parallel. They're not the same slope. Okay, so then the last one, slope AB. Okay, now I've made the first point x1 and the second point x2. Let's mix that up just so you can see that it works. So x2, y2, x1, y1. Okay, so if A is x2 and y2, so y2 would be 6 then. So 6 minus -2 over -3 minus -5. Okay, so that makes an 8. Okay, -3 plus 5 is 2. Oh, look, the slope is 4 again. So that means that the slope of EF, well, not even, the slope of EF equals the slope of AB. So that means that EF is parallel to AB. Okay, and they're not anything to CD, so we don't have to worry about that. But EF is parallel to AB. If we really want to be technical, we can put lines on top to show line EF, but that's, you get the idea. All right. Okay, non-parallel lines in the same plane have different slopes. Perpendicular lines, of course, are not parallel, so they, of course, have different slopes. So lines A and B and C and D are drawn for us, so they are drawn perpendicular. So perpendicular, of course, means at right angles or at 90 degrees to each other. And we symbolize that by that little square. Okay, so that means that that's a right angle. Okay, perfect. Okay, now, if we find the slopes of A, B, and CD, we're gonna see something interesting. So if we find the slope of AB, okay, so A and B, so they've drawn it on the graph for us. So the rise is 4 and the run is 3. So AB rises 4, run is 3. Okay, so that's 4 over 3. Now CD, on the other hand, has a run of 3 and a rise of negative 4. So a rise of 3, a run of negative 4. Now we don't usually leave the negative on the bottom, so I would say negative 3/4. Okay, well, look at these slopes. Like, there's definitely some patterns going on here. Do you notice how the two fractions are just flipped? Okay, and look, this AB is positive and CD is negative. Okay, so if you have a look at the numbers, negative 3/4 is the negative reciprocal of 4/3. Technically, numbers are negative reciprocals if they multiply to -1. So if we check this, negative 3/4 times positive 4/3, okay, equals -1. So we indeed see that these are negative reciprocals. Okay, so the relationship between the slopes of AB and CD is true for any two perpendicular lines. Okay, so perpendicular lines have slopes that are negative reciprocals. Okay, we use the term perpendicular, okay, to mean intersect at 90 degrees, and the symbol for that is an upside down T. So we would say AB is perpendicular to CD. Okay, that upside down T means perpendicular. Okay, the two slashes means parallel. Awesome. Okay, now there is one exception. Okay, horizontal and vertical lines are an exception. Now remember, a horizontal line looks like that, a vertical line looks like that. So the horizontal line, remember, that one has a slope of 0. Okay, so slope equals 0. Okay, the slope of a vertical line, though, remember, is undefined. It's like 1 over 0. Okay, so the thing is, you can't go 0 times 1 over 0 and get -1. Okay, that it doesn't work that way. Okay, so the slopes of horizontal and vertical lines are not negative reciprocals, but we still know that they're perpendicular because those are the easiest ones to see, that they intersect at 90 degrees. Okay, so with that little exception, every other two set of perpendicular lines will have slopes that are negative reciprocals. So the slope of two oblique lines, perpendicular lines, are negative reciprocals. That is, a line with a slope of A is perpendicular to a line with a slope of -1 over A. So remember, A is a fraction, so A can be written as A over 1. So what we do, if we want a perpendicular line to that, we flip the fraction, so 1 over A, and we change the sign. So if A was positive, then 1 over A has to be negative. Okay, it's pretty straightforward. Okay, example 2, examining slopes to compare lines. So line ST passes through that, line UV passes through those. Are the two lines parallel, perpendicular, or neither? Remember, parallel will have the same slopes. Perpendicular will have negative reciprocals. And if the slopes are anything else, then they will be neither. Okay, so all we got to do is figure out the slopes. So slope ST. Okay, well, sorry guys, zoomed in a bit. Okay, so let's see, x1, y1, x2, y2. So we get negative 5 minus 7 over 2 minus negative 2. Okay, so negative 5 minus 7 is negative 12. And let's see, the double negative makes a positive, so that's divided by 4. So the slope of ST is negative 3. Awesome. Okay, so now we find the slope of UV. Okay, same thing, x1, y1, x2, y2. So then we get 6 minus 3 over 7 minus negative 2. So 6 minus 3 is 3. Okay, the double negative makes a positive, so 7 plus 2 is 9. So that reduces to 1/3. Well, wait a second. Negative 3 is negative 3 over 1. So you can see that, hey, that's flipped over. So these are negative reciprocals of each other. So that means that ST is perpendicular to UV. Awesome. Pretty straightforward. Okay, example 3. Determine the slope of a line that is perpendicular to the line through that. Okay, so if we want the line that's perpendicular to that, first we have to know the slope through G and H. So we figure that out, slope through G and H. Okay, so x1, y1, x2, y2. So negative 2 minus 3 over x2 is 1 minus negative 2. Okay, so negative 2 minus 3 is negative 5. Okay, and then the double negative becomes a positive again, so 1 plus 2 is 3. So that's the slope of GH. So the perpendicular slope to this, remember we flipped the fraction, so that's going to be 3 over 5. And it was negative, so now we make it positive. So that is the perpendicular slope. Awesome, so positive 3 over 5. Okay, so again, let's recap. We find the slope of that line and take the negative reciprocal of it. Okay, so determine a possible coordinate of J so that the line GJ is perpendicular to the line GH. Okay, well, let's draw this out. So GH, so G is at negative 2, 3, so negative 2, 1, 2, 3, so that's the point G. Okay, H is at 1, negative 2, so 1, negative 2, so that's where H is. Okay, and if we draw the line through that, it just looks like this. Again, having a ruler would be handy. I'm a little curvy, but that's okay. Now, we have to figure out possible coordinates of J so that they're perpendicular. Now, we already figured out the perpendicular slope, so we need the perpendicular slope that goes through G, because we're looking for the line GJ. So we have to go through G, and we have a slope of 3 over 5. So that means there's a rise of 3. I'm going to use a different color. So we have a rise of 3, 1, 2, 3, and a run of 5. 1, 2, 3, 4, 5. So that one is a good approximation of where, well, it's an approximation. That's where J could be. So where is that? That is 1, 2, 3, 1, 2, 3, 4, 5, 6. That's the point 3, 6. So that would work. Okay. Well, the thing is, remember, we could also go 3 down and 5 left, right? This could both be negative 3 over negative 5. So I could go 3 down and 1, 2, 3, 4, 5 left. So that's another possibility for J. Now, there's lots of other possibilities, but those are the ones that are the easiest. So let's see, that's the point negative 1, 2, 3, 4, 5, 6, 7. So negative 7, 0. So those are 2 possibilities for the point J. And if we draw those, oh, look, that looks like it could be 90 degrees. Awesome. Okay, so last example. Okay, So example 4, using slope to identify a polygon. Okay, so for A is quadrilateral EFGH. Okay, so EFGH is a parallelogram, but is it a rectangle? Okay, so parallelogram means that we have two sets of parallel lines. And when you're drawing on geometry, okay, we use these kind of double arrows or single arrows to signify that those lines are parallel with each other. Okay, so that is one of the rules of a rectangle. So a rectangle has to have parallel lines, or two sets of parallel lines, but they also have to intersect each other at 90 degrees. So if these are intersecting at 90 degrees, okay, they have to have perpendicular slopes. Okay, so we're going to try and we don't have to figure out E and F and G and H because we know that they're the same slope. So I can just figure out one. So let's figure out the slope of EF. Okay, and then likewise, I don't have to figure out the slope of EH and FG. I can just figure out the slope of one of the other lines. So let's figure out the slope of EH. Now, if they're perpendicular, then the whole thing will be a rectangle. If they're not perpendicular, then of course it won't. You can be a parallelogram, but have, like that's a really skewed one. But you can tell that there are no 90 degrees angles in that one. Okay, it's still a parallelogram. It's got two pairs of parallel lines. Okay, so that's what we're trying to check here. All right, so slope of EF. And again, when we're presented with a picture, we might as well just count. So let's go from F to E. So that's 1, 2, 3, 4, 5 up and 2 right. So 5 over 2. That fraction doesn't reduce, so we just leave it like that. Okay, and then we do the same thing for E and H. So the rise is -1, and the run is 1, 2, 3. So -1 over 3. Now you can clearly see that those are not negative reciprocals of each other. So that is not a 90-degree angle. So the parallelogram EFGH is not a rectangle. Okay, so let's try for B. Okay, is ABCD is a parallelogram, but is it a rectangle? Okay, so same kind of thing. We're going to figure out the slopes of AD and the slopes of DC. Now again, you can have any pairing of those, just as long as there's the slope of one of the longer lines and the slope of one of the shorter lines. So I'm choosing AD, and let's figure out the slope of CD as well. Okay, so again, when presented with a picture, we might as well just count. So the rise is 2, and the run is 1, 2, 3, 4, 5, 6, 7, 8. So 2 over 8. Okay, now that, of course, reduces to 1 over 4. Awesome. Okay, so then CD, we have a rise. So if I start at C, we have a rise of 1, 2, 3, 4, and a run of -1. Okay, so that, of course, reduces to -4. Now, if we have a look at these numbers, okay, 1/4 and 4 over 1, those are reciprocals. And then the 1/4 is positive, then -4 is negative. So these are negative reciprocals. So that means that that is indeed a right angle. And because the slopes are all parallel, it means that they're all right angles, which means that ABCD is a rectangle. Awesome. Okay, so that's it for this section. I'd like you to practice by completing those questions. It's section 6.2 in your textbook, starting on page 349. Again, you can print them from the workspace card. That'll let you draw all over the questions. It is handy for that. So, good luck. I will see you next section. Oh, make sure you show your teacher when you're done so they can keep track of your progress. Thanks.